Good day, future RMTs. Welcome to our discussion about trace and toxic elements. Our learning outcomes are as follows. Recall the general functions of trace elements in maintaining homeostasis. To start with, let us have first the definition of what is an essential trace elements and non-essential trace elements. As we all know, there are approximately 150 elements that is listed in our periodic table of elements. They are found in nature, they are found in our environment, and most especially, it is important for us to take note that these essential or that these trace elements or elements can be found in our body. Okay? And when you said elements, no, it is considered as an essential or a non-essential trace elements. Okay? We can say that this is an essential if a deficiency impairs a biochemical or functional process, no? And the replacement of element corrects the impairment. On the other hand, non-essential trace elements are of medical interest because these non-essential trace elements, most of them or many of them, are considered toxic. Now, it is nice to remember and to take note that the decrease in the intake, impaired absorption, and increased excretion, as well as genetic abnormalities, are some of the conditions that can lead into the impairment of our or deficiency rather, deficiency of our trace elements. It is also important to take note that these trace elements are important or associated in many enzymatic reactions or other proteins such as essential components or cofactors of our enzymatic activities. However, even though that they have no important function in our body, it is also nice to take note and to remember that excess concentrations of these essential trace elements together with our non-essential trace elements can be associated with some degrees of toxicity. Take note that iron, copper, and zinc is measured or quantified using mg per liter, while selenium, chromium, and manganese is considered, no, the ultra trace elements. They are considered ultra trace elements, meaning to say that their level in the body is low, no, in terms of micrograms per liter. So those are selenium, chromium, and manganese. Now, uh, for almost many years, no, it is important, and as we all know, the quantification is one of the core concepts, or the measurement of the level is one of the core concepts of our study in clinical chemistry. It is not only on how the biomolecules or the elements like this are absorbed or produced or secreted by the body, but also how are we going to quantify and what are the specimen that we can use to quantify the level of these analytes. Because as we all know, no, and take note of this, abnormality in the levels of these analyte is the purpose why we are studying those analytes. Diba? Bakit mo po nasabi na abnormalities in the level? Eh pag may sobra, hindi maganda. Kapag may labis, meron namang physiological or biochemical processes na pwedeng maapektuhan. Okay? And usually, we have the atomic absorption spectrophotometer with either flame or flameless, or we can use the graphite furnace or the GFAAS, no, in quantifying or in measuring our trace elements. Okay? And remember that in sample collection and processing, take note that we have to consider the anticoagulants, the collection apparatus, and the specimen. As per se anticoagulant or as per anticoagulant, take note that since we are dealing with the toxicity levels and trace element analysis, usually we are using the royal blue top that contains EDTA. However, there are some trace elements that does not require the use of our EDTA because it chelates its activity. So please take note that even though that royal blue top is usually used for trace element analysis and toxicology, we have to consider also if that trace element does not require the use of EDTA. Another thing that we have to remember is that trace elements in the body has a low concentration. That's why a careful uh, a careful extraction or a careful collection of the samples must be uh, considered at all times. No, and since that they are low in biological samples and uh, the environment can affect the levels of our trace elements. No, and we have to remember that we have to avoid contaminating our specimens because contamination of the specimens or gross contamination of the specimens that we are going to use for our analysis can interfere the results of our quantification. Okay? And take note that special handling and collection devices have to considered at all times. Okay? These special sampling handling includes the use of water, the use of highly purified water or highly purified reagents. No, even glasswares have to consider because some of the glasswares that we are going to use may have trace elements that will interfere the results of our analysis. Now, I want you to take note and remember, guys, that trace analysis is not routinely done in our clinical laboratory settings, where in fact, no, in the hospitals around the vicinity or within the vicinity, no, is not capable of measuring trace elements or toxicity level of trace elements. Because as we all know and take note of this, the laboratory environment must be carefully controlled and it must be suitable for the analysis of our trace elements. That's why no, we have to take note the specimen handling, processing, and transport if we or if the laboratory where you will work is not capable of analyzing trace elements. Now, what are the conditions that is required in the environment for our laboratory? The recommended measures the recommended measures in maintaining or in controlling the environment includes uh, the placing of trace element laboratory in a separate laboratory room. Why? Because placing the laboratory or placing the area where you are going to quantify the trace element in a separate room can control the possibility of having a contamination. Okay, and aside from that, the floor or the area must use the sticky mats or outdoors. The purpose of that is to eliminate contamination. Non-shedding ceiling tiles, controlled airflow, and disposable booties. Okay, should be worn at all times. Okay, many useful measures are borrowed from those employed in semiconductor clean rooms. Please take note, no? Remember that the laboratory or the area where we are going to quantify our trace analysis or trace element analysis must be in a separate room. And the very purpose of separating the trace element area is to avoid contamination, since contamination is a great factor that will interfere the results of our analysis. In our book, no, in our reference, Bishop summarized the advantage and disadvantages of main techniques for elemental analysis. such as the flame atomic absorption, no, the GFAA, or using our what we call this uh, mga yun, graphite furnace, no, the graphite furnace atomic absorption, the ICPAS, no, ICPAS, or the inductively coupled mass or coupled plasma atomic atomic absorption, and the ICPMS, no. These table, no, enable us to show the advantage and disadvantages in terms of sensitivity. It is important to take note that the graphite furnace atomic absorption and the ICP-MS is the one that will give us an excellent result. On the other hand, selectivity, no, flame atomic absorption naman is the excellent, while GFAA and ICP-MS is just good. No? Elemental coverage, no? In terms of elemental coverage, it is the ICP na that will give us an excellent result. Okay, no, the speed of analyte, the fast the IGFA or the GFA rather, has the slowest or yung may pinakamabagal, slow ang kanyang reaction or speed of one analyte. Multi-element capabilities, no, for atomic absorption, flame, and graphite. No, what is the backdraw of multi-element capabilities? The backdraw of multi-element capabilities is yung ano, yung gross contamination of the trace elements that can be found in the preceding, no, uh, LS sample. Okay, and as you will see, GFAA will give us a excellent result in sensitivity, but the ease of operation is not good. It will give us a poor, no, result in using or in maintaining our machine. Cost for consumables very high din ang GFAA, no. If we are going to analyze everything, no, it is between flame atomic absorption and ICP-MS that will give us, no, a better result or a better experience in terms of elemental analysis. Now let's discuss atomic emission spectroscopy. No, this is a simplified principle of atomic emission spectroscopy. No, wherein there is a flame or a source. No, and these are the essential components of our AES. Now take note that the flame, no, or the source rather, okay, is where our sample is atomized at a sufficient temperature to produce excited state species. Remember, if you will recall your basic general chemistry courses, we said that once the electrons are or once the light, no, is emitted, or once we apply light or heat in our electrons, ano yung nangyayari sa electrons? The electrons becomes excited, no? Leading into excited state species. Now, what will happen? This excited species will then now emit radiation upon relaxation back to the ground state. Okay? Now, we have the monochromator. Monochromator is also known as the wavelength selecting device, and the ultimate purpose of this one is for the dispersal or dispersion of the radiation. Okay, the dispersion of radiation, and of course for the separation of analytic line from one to another. And lastly, we have the detector, which allows us to measure the radiation intensity emitted by our electrons or by our sample. Okay? Take note that liquid sample element or liquid samples containing, I don't know, Liquid samples containing element is converted into aerosol and delivered into the source. Okay? While the intensity of emitted radiation is correlated to the concentration of our analyte, and that is the basis for our quantification. Take note ha, take note that the intensity of emitted radiation, lagyan natin to ng puso, no? The intensity of emitted radiation is correlated to the concentration of the analyte, and that is the basis of our quantification. Now, another thing that you have to remember is that the flame are capable of producing temperatures. Again, the flame is capable of producing a temperature up to 3000 Kelvin. Okay? Up to 3000 Kelvin. Now, how about atomic absorption spectroscopy or AAS? Take note that AAS is an analytical procedure that is used for the quantification of elements through absorption of optical radiation by free atoms in a gas phase. No? And remember that the spectra of atoms in line spectra specific for absorbing the elements. Okay? And absorption is governed by what we call Beerus-Lambert's law. If you still remember our discussion in analytical techniques. Take note that the Beerus-Lambert's law is equals to the negative logarithm of, of 10, okay, times A1 or I1 rather, I1 over IO times lambda LCG. Okay, take note that A is the absorbance of the sample. No, this is just a review of our clinical chemistry 1. A is the absorbance of the sample. AO is the incident light intensity. Incident light intensity. I1 is the transmitted light. Okay. This one, the lambda, is for the molar absorptivity. Absorptivity. Okay. L stands for the length or the path length. And the LG or the CG rather, the CG stands for the gas phase. Okay, take note, no, take note. This is an analytical procedure that quantifies elements by free atoms in a gas phase. Free atoms in a gas phase. CG in our Beer's-Lambert's law, or Lambert's law. Okay, ito yon. Okay, is in a gas phase. Now, to make this equation short, we can simply say that absorption is equals to Kc, AKC, where K is the constant determined by the calibration constant determined by calibration, and C is the solution, okay, concentration of the analyte or concentration of the analyte. Therefore, we can have our observance. Now, if atomic emission spectroscopy has three uh, important components such as the source, the monochromator, and the detector, take note that our atomic absorption spectroscopy has four important components. What are those? We have the radiation light source, we have the atomizer, we have the monochromator, and of course, we have the detector. A radiation light source is typically the light source, no? And this is no no. This is the part of our atomic absorption spectrophotometer that emits spectrum to the analyte, no? Emits spectrum of the analyte, not to, of the analyte. Atomizer, on the other hand, is in which the atoms of the element of interest, no, the sample are formed. Now again, when we said atomizer, no, it is where the samples are formed. Again, of course, monochromator is for the dispersion of the radiation and separation of the line from another. And of course, detector is typically used for the measurement of the radiation intensity. Remember that radiation sources or radiation light sources in atomic absorption spectrophotometry uses hollow cathode lamp. It uses hollow cathode lamp, and we can also use electrodeless discharge lamp. Okay? Remember that HCl, no, not hydrochloric acid, but we have here as your hollow cathode lamp, no, contains target elements, no, in form of hollow cylinder. We also have what we call inductively coupled plasma mass spectrophotometry. This is a analytical principle, no, an analytical technique which is used for elemental analysis. Take note that the term plasma in ICP, no, refers to ionized gas. Again, take note that the plasma, no, refers to ionized gas, okay, which is typically argon in nature. Remember that Icpms measures mass to charge ratio of selected analyte ions. Okay? Mz or M over Z is typically means molecular mass of the element, divided by our ionic charge. No? Divided by our ionic charge. Okay? Now, remember that these ICP-MS this ICP-MS, no, that measures mass to charge ratio of our electrolytes of our trace elements, no, includes the following components. Ano po yun? The ion source, the mass analyzer, and the ion detector. Again, the ion source, the mass analyzer or the MS analyzer, and the ion detectors. Okay? Now, remember that the ICP instrument or the ICP-MS instrument or even the ICP-AES can generate a temperature ranging from 6,000 to 10,000 daltons. These 6,000 to 10,000 temperature or Kelvin, I'm sorry, Kelvin. Parang Daltons atang sabi ko, Kelvin. No? Again, the Icpms and even the Icpaes, no, can generate temperature ranging from 6,000 to 10,000 Kelvin. No? And there are a lot of uh, purposes or use of this temperature. What are those? It dries the droplets produced by the nebulize, no, or nebulizer. It also vaporizes dried particles. Okay. It is also used for the atomization of the molecular species, and most especially for thermal ionizes atoms. All right. We also have what we call the quadruple mass spectrophotometers and even high resolution mass spectrophotometers. There are interferences in the elemental analysis, and these interferences includes spectroscopic and non-spectroscopic. When we said spectroscopic, it is generally uh, a result of spectral overlap, which means no, which means the spectrum of the target analyte overlaps with the spectrum uh, of our principal. For example, the line spectra of the elements and the absorption spectra of the principal no, may overlap, and this overlapping can cause in falsely elevation or falsely elevated quantification of our target elements. Okay? Now, ICP-MS spectral interferences includes the following: polyatomic species whose MZ may overlap of the target elements. What is this? For example, our argon oxide. No? Argon oxide has the same or pwedeng mag-overlap ang kanyang spectra with iron. No? Another example is the argon chloride. Argon chloride, no, uh, can have an interference with our uh, tawag dito, AS. Okay? Now, the second source of spectral interference in our spectroscopic, okay, is the nearby elements in the periodic table. No, as we all know, meron tayong mga isotopes, no? Ano yung isotopes? The same element pero magkaiba sila ng not molecular mass but the atomic mass, 'di ba? That's an isotope. Kaya example of that is our tin and cadmium. No? They both have the isotopes at 114 Dalton. So, ibig sabihin, since they have the same isotopes of 1,1 per Dalton, yung line spectra nila may overlap to one another. Okay? Bakit nag-overlap? Kasi parehas sila ng measurement. Okay? And lastly, we have the double D or doubly charged ions. Take note that these trace elements, di ba kaya nga trace elements, sila yung mayroong different ionic charges. No? Sometimes they can be positive charge, sometimes they can be negative charge, or even they have what we call multiple ionic charges. For example, iron. Yung iron natin, merong ferric at merong chloride. So these double charges can interfere because of the spectra that can be emitted by their isotopes. On the other hand, we have our non-spectroscopic interference, and this is defined as the interference, no, including matrix interference. No? When we said matrix interference, it involves bulk physical properties of the sample to analyze. In other words, when we said non-spectroscopic, it means that anything that can interfere with the atomization of our sample. Now, let's discuss what are the essential and non-essential elements. Number one, we have our aluminum. Okay, aluminum is defined or described as a metal. Now, as we all know, this is a metal that can what you call this? That can promote or that can ano nga ba yung sabi sa metal? Produce heat or light. Okay? Now, what is the purpose of our aluminum in the body? Okay, meron ba? Actually, no. Remember that uh, aluminum, the aluminum plays an interference with our enzymatic activities. Usually, the source of aluminum in the body is through the ingestion or consumption of a food containing aluminum, no? Typically, in United States, 7 to 9 milligrams of aluminum ang nai-ingest ng American per day from their food. Okay? Another source of aluminum in the body is the use of antacids. What is antacid? Antacid, yung mga antacid natin, meron yung mga metallic hydroxides. One of the best examples of metallic hydroxides is the aluminum hydroxide. Okay? And that could be the source of the aluminum in the body. Now, remember that aluminum passes into the blood in a smaller amount. Okay? Take note that the plasma aluminum is bound to a carrier proteins. Example of a carrier proteins that is bound to our aluminum is no other than our transferrin. Okay? Now, uh, the toxicity of aluminum can include encephalopathy. What do we mean by encephalopathy? Take note of this. When we said encephalopathy, it means that this is a disease that affects the function or the structure of the brain, wherein the patient can experience memory loss, personality changes, dementia, seizures, coma, or even death. Again, take note that toxicity of aluminum includes encephalopathy. And when we said encephalopathy, it means that this is a disease that affects the function or the structure of our brain, including the loss of memory, personality changes, dementia, seizures, coma, or even death. Now, this encephalopathy that can be seen in a patient with toxicity of aluminum is similar to those who are diagnosed with Alzheimer's disease. Okay? So aside from encephalopathy, what else? A patient with toxicity of aluminum, no, the signs and symptoms can include uh, seizures, coma, abnormal ECG, osteomalacia. We also have the myoclonic jerks. What is myoclonic jerk? Okay. When we said myoclonic jerks, this is a sudden muscle constrictions. In other words, there is a sudden muscle spasm. Okay? Again, take note of this, no? Yung signs and symptoms associated to our aluminum toxicity may vary from acute to chronic. However, aluminum toxicity in people, no, with renal failure can be associated by the dialysis, no, because some of the dialysis uh, solutions may contain no, may contain aluminum. Okay? So again, remember that the toxicity, no, of our aluminum includes, again, encephalopathy, myoclonic jerks, osteomalacia, and even a plastic bone disease. No? Manifestations naman of aluminum toxicity includes anemia, okay, bone disease, and progressive dementia. What do we mean by dementia? Okay? When we said dementia, that is a loss of memory. Aside from loss of memory, a patient develop language problem or even problem in solving uh, and thinking skills. Okay? Loss of memory, language, problem solving skills, and even loss of thinking skills. Okay? Remember that primarily aluminum is measured by the use of Icpms or GFAAS. No? Next in line is we have our arsenic. When we said arsenic, now take note that that is a metallic and non-metallic. Or in other words, no, meron siyang metalloid or metalloid siya. Meron siyang meron siyang capability or the characteristics of being a metal and a non-metal. However, it is nice to remember that arsenic is non-essential. Okay? But even though that it is non-essential, toxicity of arsenic is important to take note. Now, the exposure of the human in the toxicity or the exposure of the human in the arsenic includes the ingestion of a food, usually a seafood that is rich in arsenic, okay? And acute toxicity of arsenic includes gastrointestinal disturbances, including diarrhea, abdominal pain, what else? Nausea, and even emesis. Emesis, I'm sorry. Emesis, ano yun? Emesis. What is emesis? When we said emesis, that is also known as puking. Emesis. Emesis. Kapag yung kaibigan mo may sinabi pero walang kwenta, emesis, no? That is also known as puke. Kagaya yung sinabi ko, walang kwenta, di ba? Okay. It is also known as puking. Okay. Bahala kayo kung paano nyo nasa basahin. Basta I know it's puking. Okay. Which is an act or instance of vomiting. Okay. Now, another type of exposure to arsenic is from the use of uh, arsenic trioxide. Arsenic trioxide is a colorless, sulat mo to ha, colorless, odorless, no, powder. And that is the most common cause of poisonous in human history. In fact, no, in fact, a dose of 0.01 to 0.05 of our arsenic or arsenic trioxide can produce toxic symptoms. And okay, 0.12 to 0.3 grams is seen to be the lethal dose or LD. No? That is the lethal dose or the LD. Okay? So again, uh, arsenic toxicity, no, exposure in the food that we ingest, water or drink, or even in the inhalation of arsenic trioxide, which is a colorless, odorless, uh, white powder, no, The toxicity dose is seen at 0.1 to 0.5 grams, while 0.12 to 0.3 grams can lead into death because that is said to be the lethal dose. Okay? Uh, how about cadmium? Cadmium is a non-essential element, no? A non-essential trace element. Cadmium is a soft bluish metal, okay, which is easily cut with a knife. Since this is a non-essential element or trace element, no, there is no known effect or function in the human physiology. However, as we define, ano nga yung sabi natin? Kapag po ikaw ay non-essential, kaya ka naging importante because of the toxicity level or because of your toxicity. Okay? Interestingly, mas mataas po yung absorption ng females kaysa sa males ng cadmium because of the iron load. Okay? So the exposure of cadmium includes inhaled in tobacco smoke and ingested in the food. Okay. Now remember that the ingestion of the amounts of our cadmium can lead into a rapid onset of what we call vomiting or even severe nausea. Renal dysfunction can be seen, no, presenting from chronic exposure to our cadmium. And remember, people, that toxicity of cadmium includes uh, renal dysfunction, nasal epithelium and lung damage, even respiratory distress. And of course, it can also affect our liver, our blood, our central nervous system, and even our uh, immune system. Now, it is important and nice to know that EDTA, or also known as the ethylene diamine tetraacetic acid, can be used as a chelating agent in cadmium poisoning. Therefore, we can simply say that those individual na mayroong toxicity of cadmium can be treated by the use of our EDTA. Now, how about chromium? If there is a one of the most important functions of our chromium, that is no other than it maintains the metabolism of our glucose, fats, and cholesterol. Primarily, the ionic state of chromium, no, na Cr or the chromic, okay, Cr3, okay, yung may ionic charge na 3 plus. No, I'm sorry, 36, 36, 6 plus, okay? Because 6 plus is, I'm sorry ha, please take note of this. No, 6 plus is absorbed, no, better. However, 6 plus is much more toxic than C3, okay? Yung ating chromium na mayroong ionic charge na 3 positive. Now, take note that chromium 3 plus is essential in the dietary elements. Okay, again, the C3, no, the C3 plays an important role in the maintenance of our in the maintenance and metabolism of fats, cholesterol. Again, ulitin natin. Chromium na may ionic charge na 6 plus is better absorbed. However, even though that this is a better absorbed, this is considered as a toxic, no, more toxic than our chromium 3 plus. Chromium 3 plus is essential in the metabolism of fat, of glucose, fat, and of our cholesterol. Now, since chromium is considered essential, therefore the deficiency of chromium is important to take note because no because it is important in the metabolism of fats, glucose, and cholesterol. Therefore, we can say that the deficiency in our chromium is characterized by the problem in our glucose level, including glycosuria, a problem in our cholesterol, including hypercholesterolemia, no? And interestingly, chromium deficiency can also decrease or lessen the sperm count and impaired fertility. Okay? Now, for the toxicity of chromium, it includes dermatitis, skin ulcers, eczema, or cutaneous contact, airway irritation, and obstruction, including lung cancer if chromium is inhaled. Next in line is we have copper. Copper in the human body is approximately 50 to 80% of our dietary intake. No? Excretion is 50% of the dietary intake in the feces, and 3% of it is in urine or sweat. Remember, no, that the exposure or the consumption or ingestion of copper from the food should not be or is equal to 10 milligrams per day. Copper is an essential trace element because copper is important component of several metalloenzymes, including ceruloplasmin. If you still remember our discussion in proteins, no? Pinag-usapan natin doon si ceruloplasmin, di ba? That is a, ano ba si ceruloplasmin? Ano siya? Siya ay isang acute phase reactant. Tama yon. Tama yung naisip mo na siya isang acute phase reactant. It is also important to take note and remember that copper is an important component of uh, cytochrome C oxidase, no, and even superoxide dismutase, no, which is important in our metabolism. Now, copper deficiency can be seen in premature infants. Take note, no, take note of this. Deficiency in our copper can lead into what we call neutropenia and hypochromic anemia. However, this neutropenia and hypochromic anemia can be seen in early stages of the deficiency in copper. It can also lead into pigmentation of the skin and general pallor and even osteoporosis. It is also important to take note that deficiency in copper can lead into what we call neurological abnormalities. Okay? Neurological abnormalities including psychomotor retardation. Matatandaan mo yung ceruloplasmin is increased sa cases ng Wilson's disease. Diba? Ano yung Wilson's disease? Wilson's disease is a neurological disorder including our liver. Kaya yung liver natin nagkakameron siya ng scars because of the depositions of copper in the liver cells in the hepatocytes. No? It is simply the accumulation of copper. Okay? Simply accumulation of copper in the liver. And take note, the classic signs and symptoms or the classic symptom or the classic signs, not symptoms, because you can see it. The classic symptoms of copper toxicity is what we call the Kayser's-Fletcher's ring in the cornea. Ano po yung Kayser's-Fletcher's ring in the cornea? That is a green-brown discoloration in the cornea At bakit nagkakaroon discoloration? Because of what? Because of the deposition of the copper. Okay? Bakit naman green? If you still remember the general chemistry, 'di ba yung green, 'di ba yung copper, nagpo-produce siya ng green light. So, meron siyang green, yung copper natin, nagpo-produce siya ng green color. Something like that. So, simple as this. Okay? Now, how about iron? Iron is important. Iron is considered essential, most especially because it is a component of our hemoglobin and myoglobin. Yung hemoglobin, yung ating color, no, yung heme, mayor niyang iron, and the myoglobin, no, the protein that can be found in the muscle. Okay? What else? Iron can be, we are exposed in iron from the food that we ingest. And it is important to take note that we have to reduce iron, no, from ferrous state to ferric state. Okay? Take note. We have to reduce our iron from ferrous state to ferric state. And take note that the ferrous state is bound to our protein. Now, it is what protein? And the transferrin, no? Transferrin. Now, it is important to note that peptide hormones such as hepcidin regulates our iron. I will write hepcidin. This is a hormone that regulates, no, iron absorption in the gastrointestinal tract, particularly in the upper gastrointestinal tract. Okay? Remember, yung ating red cells, 120 days ang circulation niya, right? And the degradation of the red cells by the spleen, liver, no, and macrophages will return our iron in the circulation. Since this is important component of our hemoglobin, as we said, essential element, essential trace element, deficiencies or deficiency of iron includes anemia. Can you know? Anong klaseng anemia yan? I know that you learn a lot about anemia. No? Anong klaseng anemia? That is what we call iron deficiency anemia. Sino yung prone sa iron deficiency anemia? Yung mga pregnant, mga bata, no? Even adults, no? And those women in the reproductive age. Now, toxicity of iron includes tissue accumulation. In fact, we have what we call hemochromatosis. So, napag-usapan na rin natin ito in liver function. No? Hemochromatosis. What is hemochromatosis? This is what we call the absorption of too much iron from the food. Okay? Now, hemochromatosis or severe hemochromatosis can lead into liver dysfunction and even hyperpigmentation. Okay? Again, or not again, additionally, no? Ano pa yung mga condition that is associated doon po sa ating hemochromatosis or severe hemochromatosis? Hypothyroidism, okay? And of course, liver cancer. Now, there are important laboratory diagnosis or important laboratory findings, laboratory procedures, not findings. Important laboratory procedures in terms of our iron. We have the total iron content. The total iron content measures the ferric bound to transferrin. Okay? Again, the total iron content measures the ferric iron bound to transferrin. We also have the PIBG. No? PIBG is usually, no. Total iron binding capacity pala. PIBC. No, PIBC at PIBG. PIBC or total iron binding capacity. Ito na, I'm sure naturo ito sa inyo sa anemia, di ba? Sa hematology. Ano lang 'yan? It refers to the amount of iron that could be bound if transferrin and minor protein bounds proteins in the serum or plasma. For further analysis or for further information, you can actually check our book table, specifically wherein our serum iron is decrease or increase, the transferrin, the ferritin, and so on and so forth. And what are the conditions such as iron deficiency anemia and even hemochromatosis. So please take note of that. So please have time to read our book, no? And specifically dun sa table that will give you an overview of what is the conditions affecting our serum level. I guess this is the fourth to the last element. This is lead. No, lead is no known function in human that is considered toxic and even non-essential. Now, the exposure of lead includes respiratory and gastrointestinal, which means no inhalation or even uh, ingestion. No, 30 to 40% of our absorbed lead is inhaled, while the GI is variable. No, excretion of our lead includes in urine, feces, and hair, even in sweat and nails. Okay? Now take note of this. Di ba, naririnig nyo na yung lead-free paint. Bakit? Kasi there are studies that showed no, that toxicity or too much exposure in lead can lead into the decline of the IQ level, no, intelligence quotient of children. Kaya di ba dati kapag pasukan, ano yung lagi nyong naririnig sa balita? Chinek ng mga taga Food and Drug Administration or chinek ng mga taga-gobyerno yung total lead content ng mga coloring materials, ng mga notebook, and mga laruan kapag Christmas. Because they showed, no, researchers showed that lead toxicity can lead into decline of the IQ. Okay? It can even cause clumsiness and gait issues. Ano naman yung gait issues? This is or gait abnormalities. This is a condition wherein an individual is unable to walk, no? Unable to walk in a usual way. Toxicity can also include headache, behavior changes, no, seizures, and cognitive. No? Kaya nga, IQ level mababa in relation to our cognitive, such as remembering, understanding, analyzing, and so on and so forth. If you still remember the Bloom's taxonomy, di ba? Yung mga words doon is to measure the cognitive understanding or cognitive level of the students. Now, it also includes peripheral neuropathies and even motor weakness. Liver can be, renal pala, kidney can be associated. Now, take note, people, that the specimen of choice for lead determination is venous whole blood. Okay? Venous whole blood. Why? This is venous blood is preferred over plasma or serum because of the circulating lead that is predominantly associated in our red cells. O, tandaan mo ha, the specimen of choice is whole blood. Bakit? Because of uh, the circulating lead that can be found in the red cells or associated in the red cells. Therefore, if we are going to use capillary blood and the level of our lead is increased, no, it is important to collect venous blood sample for confirmatory of lead uh, measurement. Next in line is a mercury. Mercury is known in the function of the human. It is even a toxic, no? And the exposure of mercury can include ingestion and inhalation. Ingestion primarily from uh, fish, yung mga toxic fishes. Okay? Inhalation including elemental mercury vapor. No? What else? Ayun nga, yung fish, yung mga toxic, yung mga nakakalason na isda. And even tattoo. No? Kapag yung ginagamit is tawag doon, contaminated with mercury. Before, diba? Before, yung pong mga pasta ng ngipin, may mga mercury yon. Pero after several studies, no, they found out that mercury is a poisonous, a toxic, kaya inalis na nila yon. Okay? And take note, people, that the major organ involved in the storage of elemental and inorganic mercury exposure is not is no other than our kidneys. Okay? Huh? So those are the toxicity, the signs and symptoms of a patient with toxicity, no, of our mercury. Next in line is a manganese. This is an essential trace elements. Why consider this essential? Because this is a component of several metalloenzymes and even an enzyme activator. Okay? Um, Manganese containing enzymes includes manganese superoxide dismutase, okay, in the mitochondria. Manganese is also important in our blood clotting. That's why if you have a deficiency in manganese, meron kang blood clotting defects. Okay? Blood clotting defects. It is also associated in hypocholesterolemia, no, dermatitis, heart and bone problems, and even stunted growth. Okay? Now, what are the signs of symptoms experienced by the patient, with toxicity of manganese? We have nausea, vomiting, headache, disorientation, memory loss, anxiety, compulsive crying or laughing. Okay? And take note that chronic toxicity of our manganese is associated, or not associated, resembles, yon, that's the right term, resembles to those patients with Parkinson's disease. Parkinson's disease, alam mo naman, yung sobrang pangangatal, no? With akinesia. Ano yung akinesia? Yung kapag sinagot ka niya, akinesia. Wala na namang kwentang bagay, no? Kapag sinabi natin akinesia, ano akinesia? Hindi pala, iba pala yun. Okay? Kapag sinabi natin akinesia, it means that the loss of ability to move. Ayan, dahil iyon na siya, hindi ka makamove. Tandaan mo yun, no? Dahil iyon na siya, hindi ka makamove, akinesia. A loss of ability to move muscles voluntarily. Okay? Next in line is we have the molybdenum. Molybdenum is a essential component of our body, and it is a important component of at least 3 enzymes. Ano po yung mga enzymes na yon? Let's enumerate. Wait, I'll show you a black screen because I will write those enzymes. Let me just change my pen, the color of my pen. Okay, so again, like what I've said, no, molybdenum Molybdenum is an important component of three enzymes. Ano po yung three enzymes na yan? Madami naman, pero itong three enzymes na yun, no? Ito yung mayroong pinaka importante na si molybdenum is yung pinaka isa sa importante nilang uh, activator. Okay? Number one is we have the aldehyde oxidase. Aldehyde oxidase. What is aldehyde oxidase? Aldehyde oxidase, no, is a molybdenum containing enzyme involved in the clearance of compounds containing what? Aldehyde. No? Important, no, important in the clearance of compounds containing aldehyde, no? And even compounds containing heterocyclic fragments. Okay? That is aldehyde oxidase. So si uh, molybdenum is important component of the aldehyde oxidase as an activator. The other enzyme, no, that requires molybdenum is what we call the sulfite oxidase. Sulfite oxidase. Okay? So ito ay uh, clearance of compounds containing aldehyde, definitely. Okay. Now, for sulfite oxidase catalyzes the oxidation of sulfite to sulfate. No? Catalyzes oxidation from the, kaya nga oxidase, no? Oxidation of sulfite to sulfate. Okay? The terminal reaction in the oxidative degradation project or degradation process of a pathway containing sulfur. Again, take note that sulfite oxidase, no, an enzyme that contains molybdenum, catalyzes oxidation of sulfite to sulfate, which is a terminal reaction of the oxidative degradation of processes or pathway containing sulfur amino acids. And last but not the least is we have our Santine oxidase. What is with Santine oxidase? This enzyme catalyzes the oxidation of hypocyantine to xanthine. No? Catalyzes the oxidation of hypoxanthine to xanthine. Okay? Aside from that, this enzyme is required not to produce uric acid by the breakdown of purine metabolism or purine nucleotides. Okay? So please take note of these three enzymes na merong molybdenum, no, importante si molybdenum. Why? Because these enzymes, the active sites of these enzymes forms or binds with the active site of the enzyme. Okay? So those are the toxicity and uh, conditions in association to the deficiency of molybdenum. Now, how about selenium? Selenium is considered as an essential trace element. Why considered as an essential trace element? Because that is considered as an important antioxidant defense of our body against uh, free radicals. But bago siya makilala as a essential, you know guys that selenium in the year 1930, no, in the year 1930, sino ating pangsulat? Kasi nga pala puti. Okay. Bago siya makilalang essential, no? In the year 1930, they believed that selenium is a toxic element, no? A toxic element. In the year 1940, kinalasify nila as carcinogenic. Carcinogenic. Okay? Pagdating ng 1950, sabi nila, hindi siya carcinogenic. Siya ay essential element. And in the year 1960s, no, every 10 years, merong development kay selenium. In the year 1960s, no, nakakita sila ng characteristics of selenium contradicting their findings in the year 1940. Kasi nang sabi nila, ito ay anti-carcinogenic. Bakit siya naging anti-carcinogenic? Because of its natural antioxidant defense against free radicals that can cause carcinogen, or that can cause, no, uh, not really can cause, but can trigger. Okay, that's the right term. Can trigger the development of cancer cells. And lastly, it is important to take note that selenium is an important factor in the metabolism of our thyroid hormones. Okay? Exposure includes food that we ingest and drink, or drinking water that we consume. Okay? Toxicity includes cardiomyopathy. Excretion is in the urine, feces, and sweat. Bakit ito sinabi ko? Deficiencies includes cardiomyopathy, muscle weakness, and osteoarthritis. My God. And I guess the last, zinc. No? Zinc is a essential trace element that influences for more than 300 enzymatic reactions, including synthesis and metabolisms of our proteins. Zinc is also important in the glycolysis and even in cholesterol metabolism. The same thing goes with chromium, 3 plus. Okay? Absorption occurs in the intestine, and the blood, or the zinc in the blood, is distributed between the red cells and white cells, no? Primarily in the red cells, because 80% in the red cells and and in 3% only in the white cells. Okay? Zinc is relatively non-toxic naman. However, lagi may however. However, even though that this is considered non-toxic, relatively non-toxic, too much exposure or high doses of zinc, which accounts to 1 grams, or repeated doses of zinc, no, can cause toxicity. Okay, which includes toxicity in the gastrointestinal tract, no, decreased heme production or synthesis, and copper deficiency, and even hyperglycemia. Kasi nga, it participate, deficiency, no, and toxicity, no, participates ang zinc sa ating glycolysis. Okay? So, toxicity includes GI tract symptoms and decreased heme synthesis, as said a while ago. Now, take note of this. The exposure in what we call zinc oxide, okay? The exposure into what we call zinc oxide can cause what we call the zinc fume fever. Zinc fume fever. What is this? This is a toxicity with zinc, no, including chemically induced pneumonia. Usually, kapag pneumonia, infectious ang may cause niyan, di ba? Bacteria or virus. But zinc fumes or zinc fume fever from the zinc oxide can trigger or can cause pneumonia. And that pneumonia is called chemically induced pneumonia. A patient can also experience fever, hyperpenia, or even coughing. And that is the end of our discussion in trace elements and toxic elements. As to synthesize everything, elements that can be found naturally in the environment and even in our body also plays an important role in our metabolism. However, not all trace elements are considered essential. No, essential trace elements is called essential because its deficiency or abnormality in the level of these essential trace elements can affect no our physiological processes. Non-essential is of medical interest, not because of its effect in the metabolism of the biological processes, but because of its toxicity associated to our trace elements. As kagaya po ni electrolytes, being element also, trace elements is also important. However, mas mahirap yung ating analysis of our trace elements because it includes uh, high-end analytical techniques such as atomic absorption spectrophotometry or spectrophotometry, the AES, the atomic emission spectrophotometry, and even the Icpms or the ICP-AES. And aside from that, we have to consider the specimen collection, processing, transport, as well as the storage in terms of elemental analysis. And lastly, we have to remember that the laboratory for trace element analysis must be in a separate area to eliminate the contamination of our trace elements. Okay? So once again, thank you very much and I hope you learn. I have here a QR code. Please scan this QR code and evaluate your satisfaction. I don't know why you have to do that, but we have to follow the order of the institution that every end of the session, you have to scan the code and evaluate your satisfaction. Once again, thank you very much and God bless you all.